In this video, we are going to discuss about solids. At the end of this lesson, students should be able to explain the fixed shape of a solid. Then, explain the freezing, melting, sublimation, and deposition process based on kinetic concept. Students also need to differentiate between the amorphous and crystalline solids. And state the examples of metallic, ionic, molecular covalent, and giant covalent solids. Let's start with the properties of a solid. Solid is one of the three main states of matter, along with liquid and gas. Matter is the consists of atoms, molecules, or ions that make up all physical substances. In a solid, particles are packed closely together and are not free to move about within the substance. The molecules are strongly held and arranged in order. They can only vibrate and rotate in fixed position. Therefore, solids have a fixed shape that is difficult to change. Solids also have a definite volume. That is, they keep their size no matter how you try to change them. A solid is rigid and cannot be compressed easily because the particles are closely packed and the intermolecular separation is very small, which cannot be reduced further. A solid also does not diffuse into another solid easily because the intermolecular forces of attraction between the particles is very strong. A solid does not flow and can be stored in a container. The intermolecular forces of attraction is so strong that the molecules do not flow and leave the surface of a solid. Let's take a look at the types of solids. Solids are divided into two main categories. There are crystalline solid and amorphous solid. We can differentiate the crystalline solid and amorphous solid by the following properties. In crystalline solid, the atoms vibrate in place in a fixed pattern, while the amorphous solid, the atoms vibrate in place in more random arrangements. Crystalline solid can be described by the types of particles in them and the types of chemical bonding that take place between the particles. There are four types of crystalline solid. There are metallic crystal, ionic crystal, molecular covalent crystal, and the giant covalent structure crystal. Let's take a look for a metallic crystal. The metallic crystal solid consists of metal cation that's surrounded by a sea of delocalized valence electrons that forming metallic bond. For example, in sodium, magnesium, and aluminium. The metallic crystal has high melting points, high conductivity, lustrous, ductile, and malleable. In ionic crystal solid, they are consist of cations and anions that held together by electrostatic forces of attraction of opposite charges. They form an ionic bond. For example, in sodium chloride salt. Ionic crystal has a high melting points, hard and brittle. They also can conduct electricity only in their molten states or solution, and they are also thermally stable. Molecular crystal solid consists of atoms of molecule held together by intermolecular forces that includes van der Waals forces or hydrogen bonding. For example, solid water, which is ice, or solid carbon dioxide, which is called as dry ice. The molecular covalent crystal usually has low melting points. They are soft and brittle and non-conductors. They also have a weak intermolecular interactions. For a giant covalent crystal solid, there consists of atoms that held together in large network or chains by the covalent bonds. For example, in diamond, graphite, or silicon dioxide. Giant covalent structure crystals are usually has higher melting points. They are hard and rigid in a giant covalent network structure. They are also non-conductors of electricity except for graphite. And they also have a strong intermolecular attractions. The phase changes that involve solids. Why do phase changes occur? The phase changes typically occur when the temperature or pressure of a system is altered. When temperature or pressure increases, molecules interact more with each other. When pressure increases or temperature decreases, it's easier for atoms and molecules to settle into a more rigid structure. When pressure is released, it's easier for particles to move away from each other. Solid, liquid, and gas states are interconvertible. They may undergo melting or freezing process, vaporization, condensation, and sublimation. Melting is the process by which a substance changes from solid phase to a liquid phase. For example, such as an ice cube melting into water. A solid changes into a liquid when the solid is heated. The particles will gain energy and able to vibrate faster and more energetic. At its melting point, particles possess enough energy to overcome the attractive forces between them. Thus, particles are able to move freely and solid changes to liquid. Freezing is the process through which a substance changes from a liquid to a solid. All liquid except helium undergo freezing when the temperature becomes sufficiently cold. For example, such as freezing the sweetened cream into an ice cream. A liquid changes into a solid when the temperature of a liquid is lowered. The kinetic energy of the liquid particles decreases. Thus, the liquid particles vibrate at a lower rate. When the intermolecular forces are strong enough to hold the particles together in a fixed and orderly arrangement, the liquid will freeze. Sublimation is the transition from a solid phase to a gas phase without passing through an intermediate liquid phase. For example, such as a sublimation of dry ice or the solid carbon dioxide into carbon dioxide gas. A solid changes into a gas when the temperature is increases or the pressure is decreases. The kinetic energy of particles will increase. This allows the particles to overcome the intermolecular forces and escape the solid to disperse as a gas. Deposition is the process where molecules from vapor phase change directly to the solid phase without entering the liquid phase. For example, such as the water vapor from winter air deposit directly into a solid crystalline frost on a window, without ever being liquid in the process. A gas changes into a solid when the temperature is decreases or the pressure is increases. The kinetic energy of particles decrease. The supercooled vapor immediately begins to condense, but by this point is already past the freezing point. This causes the vapor to change directly into solid. Vaporization or evaporation is the process by which molecules undergo a spontaneous transition from a liquid phase to a gas phase. For example, such as the vaporization of alcohol into its vapor. A liquid changes into a gas when the temperature is increased. The kinetic energy of molecules increases. The force of attraction between the molecules reduces. Thus, liquid molecules escape into surrounding in the form of vapors. Condensation is the process by which water vapor in the air is changed into liquid. for example, such as the condensation of water vapor into dew drops. A liquid changes into a gas when the temperature is decreased. The kinetic energy of the molecules decreases and get closer together. The force of attraction between the molecules getting stronger and the vapor change to liquid.